Okay, I'm going to follow up with another video on math shortcuts and how they work. In this video, we'll be focusing on multiplying 2 and 3-digit numbers. But let me review quickly what we did last time. On the previous video, we looked at a procedure for squaring, a shortcut for squaring a 2-digit number that ends in 5. Okay, I went ahead and used the formula for squaring the difference and sum of binomials to show you how it worked. But here's what we did. Here's what the shortcut was. We take the first digit and add 1 to it, we get 8. Multiply the 8 and the 7, we get 56. And then it's always going to end in 25. So there you have it. That was the rule. For a two-digit number that ends in 5, take the number in the tens place, which in this case is the 7, add 1 to it, you get 8. Multiply the 8 and the 7, that's 56. And then of course 5 squared is 25, and the answer is always going to end in 25. There it is. Okay. Another shortcut we had was multiplying a number by 11. Okay. Say a 2-digit number by 11, and in this case the shortcut was to simply bring the 1 over and then the last digit 7, and then add the 2 digits 1 and 7, we get 8. Okay, so 17 times 11 is 187. The only thing about it was if you had something like this, like 38 times 11. Okay, again, a 2-digit number times 11. Again, bring down the 3, and then leave some space. Put down the 8, and then you add the 2 digits, 3 and 8. Now, if you get a number 10 or larger, in this case, you do a carry. So, in this case, 3 and 8 is 11. So, bring 1 there, and then you carry the 1. And this comes out to 4, 18. So in this particular case, we're basically using 2-digit numbers. This rule that I use right here, you can use it for 3-digit numbers as long as the number ends in 5. But the calculations are going to be more involved, so it's really not worth it. Okay, it's not going to be really a shortcut in that particular case. But anyways, if it's a 2-digit number that ends in 5, or you're multiplying a 2-digit number by 11, very easy to get the answer. Clear this. Okay, like I said, the focus in this video is going to be multiplying 2 and 3-digit numbers. Really, we want numbers that are close to 100. Okay, it could be numbers close to 1,000, but let's just say 100 for right now. Okay, so let's say we have 97 times 95. Okay, here's the way the rule works. Again, we want numbers that are close to 100. So 97, 95 are close to 100. So the rule is, how far is 97 from 100? So just subtract it from 100, we get 3. 95, again, subtract it from 100, it's 5 units away from 100. And then you simply add these two numbers. We get 8. And then you subtract the 8 from 100. We get 92. And then multiply the 2 digits out. 3 times 5 is 15. So the answer comes out to 9,215. Okay, so you can do that all in your head. You get 97 times 95, again, 3 and 5. 3 and 5 is 8. Subtract it from 100, you get 92. And 3 times 5 is 15. That's all there is to that method. Okay. Now, can you do it for something like 85 and say 72? Will this work? It will, but the calculations are going to be a little bit more involved, so it's really, I can't consider that a shortcut. Okay, makes it easier if the number is close to 100. So let's clear this. Now, I want to show you the shortcut, but at the same time, I want to show you also why it works that way. Okay. So right here, this is kind of what I did in the last video to demonstrate why the procedure works. I simply wrote 97 as 100 minus 3. And I wrote 95 as 100 minus 5. Okay. And then I just multiplied this like they were two binomials. X minus y, x minus y. Okay. Or x minus z, something else. Okay. And then I say, okay, 100 times 100, I got 100 squared. Minus 5 times a minus 3 is the 15, thus I get this one. And then we do the inner product and the outer product over here. So we get minus 300, and then over here minus 5 times 100. So I get negative 5 times 100 and negative 3 times 100. Combine those, and I get minus 8 times 100. And then, of course, minus 5 times the minus 3 is the plus 15. Okay. And then I simply said, okay, 100 times 100 can be written as 100 times 100. Okay, so now you can subtract right here. Okay. So you have the same factor of 100 and 100. Minus 8 from 100 is 92. Okay, and that's why over here I said just subtract, add these the two. This is 3 away from 100, and this is 5 away from 100. That's why I said here add the two values. That's 8 subtracted from 100. And notice here, this is where I got the 92 over here. Right, minus 8 times 100 is 92 times 100. And then of course here you got the 15. So 92 and 100 is 9200. Okay, so I got two zeros right there, but I'm adding 15 to that. Okay, so that's why it works. Okay, so it's going to be very easy to do these types of problems if you have two numbers close to 100. So right now in this video, I'm going to look at numbers that are less than 100. Well, I'm going to look at the case where both numbers are less than 100. Okay. In the next problem, do this, and again, if I'm going too fast, kind of stop the video and check it out to make sure it makes sense. But I'm going to clear this. Okay. Now, this one, do another one like this now. Okay. So again, look at it quickly and see if you can come out with the answer. Okay. So this is 1 from 100. This is 2 from 100. Okay. Subtract, add these up, we get 3. Subtract 3 from 100, we get 97. And then 1 times 2 is 2. And of course we had the 0, 0 here, so we get 9,702. 9,702. That's how easy it is. Okay. Again, 1 and 2, add it up, subtract it from 100, that's how I get the 97. And then multiply the two digits out. 2 times 1 is 2. And that'll be at the end. But remember, it comes out to 0, 0 there. Okay, so it's like adding 2 to the 9,700. Okay, and it follows because of the same rule over here. Okay, let's clear this. Okay, so now we looked at some examples when both numbers were less than 100. Now let's look at the case where both numbers are greater than 100. Okay, so again, in this case, this one is, this. In this case, this is 3 more than 100. This one is 5 more. Okay, so in this case, what you're going to do is add the two numbers again, but you're going to add it to 100. Okay, so this is going to be 108. Okay, so 3 and 5 is 8, and you added 200, so it's 108, and then you multiply the 3 and the 5 out, you get 15. Okay, and then 10,815. Okay, so in the first couple of problems, when the two numbers were under 100, we subtracted the sum of those values from 100. In this case, we added the values to 100. Do this. And now this is why it works the way it does. Okay, so I took the 100 and I wrote it as 100 plus 3. The 105 I wrote it as 100 plus 5, and then just multiply this. Okay, just like multiplying binomials. So the first term, 100 times 100 is 100 squared. And then 100 times 3 is 3 times 100. 5 times 100 is 5 times 100. So 300 and 500 is 800 right here. And notice in the previous one, this was a minus. Okay, so it was subtracted. And now I write 100 squared is 100 times 100. So here's way. Okay, now these are like terms. So the 100 and the 8 can be added. And of course, the 100 comes along for the ride. So I get 108 times 100. And then of course, the 3 and the 5 are multiplied, you get 15 over here, so this comes out to 10800, and you add the 15 to that, and you get 10,850. Okay. So these are some shortcuts that you can impress some of your friends with, or just use it in your normal studies. I do want to show you that these are the two formulas that I was using, okay, to show the results. X plus y squared, square of a binomial, is x squared plus 2xy plus y squared. And if you have the difference of x and y squared, it's x squared minus 2xy plus y squared. Okay, so that concludes the video. I hope that was entertaining, and I hope it made sense. I will follow up with more videos on shortcuts in mathematics in general, and I do have some coming up in algebra, along with some technology and some plumbing and so forth. Okay, so that's my dog barking in the background. But anyway, thanks for watching. We'll see you in the next video.